Welcome to this video of number theory. Number theory is concerned with the properties of positive integers. The positive integers is also known as the natural numbers or the counting numbers. In this video, I will talk about the principle of mathematical induction. The principle of mathematical induction can be derived from the well-ordering principle. The well-ordering principle is one of the properties of natural numbers that states that every non-empty set of non-negative integers contain a least element. The well-ordering principle is true only for natural numbers. The principle of mathematical induction has two specific properties. Property 1, the integer 1 belongs to the set of positive integers. Property 2, whenever the integer k is in the set, the next integer k plus 1 must also be in that set. Let us have some example. Prove using the mathematical induction that the sum of the sum of the squares of a consecutive integers is equals to n to n plus 1 multiplied by n plus 1 over 6. If n is equals to 1 using the principle of mathematical induction where 1 belongs to the set, we will have 1 square is equals to, by substituting 1 to the right-hand side of the equation, we will have 1, 2 plus 1, 1 plus 1 over 6, that is equals to 1. For property number 2 of mathematical induction, if n is equals to k, we will have 1 squared plus 2 squared plus 3 squared plus the k squared is equals to k, 2k plus 1, k plus 1 over 6. We simply substitute k for n. Now, whenever k is in the set, k plus 1 must also be in the set. So if n is equals to k plus 1, we will have 1 squared plus 2 squared plus 3 squared plus k squared plus k plus 1 squared is equals to k, quantity 2k plus 1, quantity k plus 1 over 6 plus k plus 1 squared. We simply add k plus 1 to both sides of the equation. Now, working with the right-hand side of the equation, we will have k, 2k plus 1, k plus 1, 6, quantity k plus 1 squared by cross multiplication or by simplifying. So they have the common denominator 6. So we simply multiply 6 by k plus 1 to get this equation. Now, by factoring k plus 1 here, we factor k plus 1. What is left in the equation is k, 2k plus 1, plus 6, 6k plus 1 over 6. And by simplifying, we will have, so k multiplied by 2k is 2k squared, k multiplied by 1 is 6 is k, 6 multiplied by k is 6k, so 6k plus 1k is 7k, and then 6 multiplied by 1 is 6 over the same denominator 6. And then we factor the inner part of the equation. We have 2k squared plus 7k plus 6k is 2k plus 3 quantity k plus 2 over 6. So this complete the induction, which implies that k is in S whenever k is also in S.